In this video, we'll write the net ionic equation for PbNO3 plus Ki. That's lead 2 nitrate plus potassium iodide. So the first thing we need to do is predict what the outcome of this equation is going to be. So to do that, you have to understand how to find the charges on ions. Let's start with Pb. This is a transition metal, so its charge, it's going to vary. So instead, we'll look at the NO3, the nitrate. You can look this up on a table of common polyatomic ions, or you can just know that this has a 1- charge. Since we have 2 times the 1-, this has to be 2+. So that's the charge on the Pb. K, that's potassium. That's in group 1 on the periodic table. Those all have a 1+ charge. And then iodine, that's in group 17, sometimes called 7A. That has a 1-. So we have these charges here. So this is a double displacement reaction. The positive here is going to go with the minus here. Pb2+, that'll go with the I-. And note, if this is 2+ and this is only minus, we need 2 of these. The positive potassium ion will go with the negative nitrate. So we'll end up with KNO3. So this is what we might get with the equation. So let's balance this molecular equation. First, we have 2 I's here. So let's put a 2 in front of the Ki. We have 2 K's. So let's put a 2 here. And we have 2 NO3s. That's okay. So this is balanced molecular equation. Now we need to write the state for each one of these. We'll assume both of these are dissolved in water, that they're aqueous. So we'll put a little AQ after them. And then on this side of the table, the other thing that you really need to be able to do is to figure out if these are soluble or insoluble in water. You can either memorize solubility rules or you can look them up on a chart. There are links in the description for this video that explain how to do that. If you look them up, you'll find that PbI2 is insoluble. That means it's a solid. You'll find that the KNO3, that is soluble, so it's going to dissolve, it'll be aqueous. So these are the states for all of the compounds in this equation here. So that's our molecular equation balanced, and we wrote the states. Next up, we're going to split all the soluble compounds into ions. The soluble ones, those are the ones that are dissolved, the aqueous ones. So let's split them up. We've already done these. Pb2+, and I won't write aqueous after everything right now. Then we have NO3-, and we have 2 NO3 minuses. So we need to put that 2 nitrate ions plus potassium. We have 2 potassium ions, and then we have 2 iodide ions. Let's make this a little smaller. On the product side, our PbI2, it says it's a solid. So that means that it's at the bottom of a test tube. It's not going to dissolve or split into ions because of that solid. So we'll just write PbI2 for that. Plus our KNO3, that'll break up, and remember that's plus, so 2K plus 2 nitrate ions, NO3-. Let's tighten this up some. This is the total ionic equation. So we have our molecular equation, and we have the total ionic. Now we're going to cross out spectator ions. These are ions that really don't do anything. They're just floating around. They're not forming any compounds. We're going to cross those out on both sides, and that'll complete our equation. That'll give us the net ionic equation. So we see Pb2+ here. We don't see it over here. It's all bound up with the iodine. NO3, we have 2 of those. Yep, we can cross those out. K+, we have 2 here and 2 here, and then 2I-, nothing on this side. So what's left is the net ionic equation. That'll look like this. We can put our states in. And that is the net ionic equation for PbNO3 plus Ki, lead 2 nitrate plus potassium iodide. So 2 things you need to know. One is to figure the charge out on these ions here. And the other is to look these up on a solubility chart or to have the solubility rules memorized. This is Dr. V, and thanks for watching.